Welcome to the last session of the Data and AI Day of Devtoberfest. And with that, I'm actually already going to hand over to Maximilian, who's our speaker today, and he will talk about PromptOps. I'm extremely curious about this session because I think I have a lot to learn here.
Thank you, everybody. Hey, guys, my name is Max. I'm an AI engineering manager at SAP, and I'll talk a little bit about, let me share my screen here, and let me know if you guys can see it.
I gave you rights, so it should work, but just a sec.
Okay, here we go. Can you guys see my screen?
Yeah.
Yes? Okay,
Yeah. Yeah. Perfect.
awesome. Let me just go to full screen here. You guys
Looks
can see the
good.
full screen?
Yeah. Perfect.
Awesome. Okay, so I'm going to talk a little bit about lifecycle management of prompts for code-based agents. Um, with that, I quickly wanted to jump into the space software 3.0 in general, talk a little bit about what some figureheads in the industry are talking about when it comes to agents and how they will transform software as a service solutions and yeah, essentially all of our lives, right? So Satya Nadella, the CEO of Microsoft, said this sentence: AI agents will replace all software. I think this is obviously a gigantic one, right? What does it mean? It means for SaaS providers, for software providers all around the world, that we will have to reinvent to some degree our product portfolio with an agentic AI native mindset, right? To not just sprinkle agents on top, but most likely put them into the core software design principle of every solution that we build, right? I'll get a little bit into why I think he's absolutely correct in this later. And another quote that fits very well with that is from Jensen Huang, the CEO of NVIDIA. IT teams will become HR teams of AI agents. And I think what that kind of means is that if every software backend will become agentic and AI agents have a higher level autonomy of what they can do in our systems than traditional software, then they will also, well, as we all know it, take to some degree away the lower level automation tasks that humans are currently doing on software 1.0 backends. Those will be performed by agents. And so if they are performed by agents, then who is responsible for that agent's action, right? If we make a simple example, imagine we're some manufacturing company, and for our supply chain processing software, we have agentic software, and the agents are now sending packages onto pallets onto ships around the world, right? Sending our products that we're purchasing, that we're manufacturing somewhere around the world, and the agent is making a mistake and sending our product to the wrong client, right? Booking it onto the wrong ship. Then who's responsible for that agent's shortcoming? It's maybe not the supply chain department anymore of that company, because this AI agent is operated as software, as any software will be, by the IT department of that company. So now the responsibility shifts a little bit and is somewhere in the middle, maybe even so leaning towards the IT department, because maybe our supply chain department can't even understand what the agent did or process or go into the system to understand why the agent made a wrong decision. In this case, it needs an IT person to do that, at least to some degree, right? So this is an interesting sentence. I think will fundamentally also transform how, yeah, every corporation is set up. I think we'll see an increase in IT departments all around the world, and a decrease to some degree on other departments, right? Core corporate function departments. Software is changing again. I call it software 3.0. Andre Karpathy, the founding member of OpenAI, said, I kind of want to piggyback ride off of this thought leadership in the agentic AI space and show you a little bit why we believe in why I believe there is a new type of software now fundamentally with agentic AI. Massive shifts coming to the industry. Software software as a service as we know it is probably done and needs to be reinvented with agentic AI at the core. And maybe diving a little bit into why I believe this is the case, I want to take a look at the logic layer of the different software types, right? So if we look at traditional software, software 1.0, right, as Andre Karpathy calls it, the logic layer of software 1.0 is the code, right? So if we go back to our supply chain system, for example, what's possible and how I can book a pallet onto a ship, that's defined by code clearly, right? So I can digitize a full business process with the, we go with one supply chain, or we go with a procurement example, right? SAP has procurement software with Ariba. Um, digitize a full business process with code, and this is what we've been traditionally very good at also at SAP. The consumption mechanism for the user then is typically UI or API based. The next layer of software is kind of narrow AI machine learning models, right? Software 2.0, where the logic layer of the software is defined between code and data and manifests itself as the trained weights, right, that are behind a, for example, neural network, right? If we're looking at a machine learning model, neural network, some other classification model, doesn't matter. We're typically optimizing a cost function, right, with machine learning, and we're training some weights. So our logic layer is now the inherently learned weights, right, that are the output of a training process on data that was performed by code, right? The code defines the training process. And where this is really interesting is how how it impacts business in the abstraction layer, because as opposed to software 1.0, right? Software 2.0 still needs an existing software 1.0 backend to function, right? So software 2.0 might be the key plugin to an existing software 1.0 backend, but it can never replace it fully, right? So if we think of let's think of a sales software as a service solution, right? So the sales forecast might be a machine learning model, and it's very important to have the sales forecast for next quarter to do my demand planning or whatever. But if I don't have the software 1.0 backend to do demand planning in, then the sales forecast is just a number, right? So it's typically a UI API dashboard consumption mechanism, but it's just a plugin. It doesn't completely replace software 1.0. Facebook is a good example, right? Facebook app, and then the app machine learning model that predicts what's the next item that you're going to see in your news feed, right? It's a key plugin, but it only exists in the context of the app itself. Now with software 3.0, fundamentally different. Software 3.0, the logic layer is code and prompts, right? So I can define my logic in code still, but I can also define my logic in a prompt that's being sent to an LLM that now brings in probabilistic nature into this application, right? So some inherent fuzziness. And with that, now again, the digitization of a full business process is possible without software 1.0, right? I can still have the same code that I had in software 1.0, but I can infuse it now, not just on top as a plugin, but directly, in the core business process itself, that I now digitize as an agentic flow, for example. And the consumption mechanism is different. It's now chat interface, right? MCP A2A. I don't need traditional UI anymore. I just go give my agent a task, and the task can be way higher level than going into a UI and clicking 20 different things. I now give one overarching task, right? We see this very, very strongly, for example, with these coding agents, the GitHub Copilots, the Claude Codes and Clients and cursors of this world, right? Where we just see that the developer is giving a higher level task, do this and that for me, and then the agent goes and does it, right? So digitization, in this case, the business process is coding, but we see the digitization of a full business process now being possible with software 3.0 in some hybrid mode with software 1.0, but now being very, very disruptive, and essentially, the need to reinvent our business process with software 3.0 solutions. Why would we go to software 3.0 over software 1.0? Quickly wanted to talk about that. Why is software 3.0 better than software 1.0? And I think the answer to that lies in the probabilistic nature of the LLM, of course, right? So I have superior logic layer because I have an intelligent component in the large language model that I can pair with my deterministic logic in the code. So essentially, when I try to explain this to people, a good example is my app can react dynamically and intelligently to different edge case scenarios that the user might want to consume without us developers having to explicitly code for them. So not everything that the app can do has to be one-to-one completely premeditated, right? In the software 1.0 world, I would have to write an if-else clause for every edge case. If it's this, then do that. If it's this, then do that. Well, with Software 3.0, my app can do something that I maybe have not thought of prior, but due to the probabilistic nature of the LLM, it can do it now. So this does not only bear benefits, it bears risks, because of course the probabilistic nature can also lead to the app doing something wrong, right? Which is then very bad for me. So our engineering challenges and the skills that good Software 3.0 engineers going forward will have is how can they best leverage the benefits but mitigate the risks, right? For example, guardrailing LLM output. You're allowed to go here, dear app, but you're not allowed to go here. How can we best do that? So we won't design any more specific, only, very premeditated exact sequences of actions that our apps can do, but we will more so design for patterns, design for flows, and then guardrailing saying this is the playground on which you are allowed to operate and play, but you can't go outside of these boundaries, right? And so the design patterns of our software will change too, very drastically, in fact. Now, that having said that, right, there's of course still always a place for software 1.0, right? An LLM cannot calculate the square root of 10. It will still call a tool for that, a calculator, in fact, and do the square root of 10 via the calculator. So it's now this mix of code and prompts, right, of code and LLM flows that together will, have this new superior logic layer that will do parts of what the human previously did, but also parts of what the Software 1.0 app will previously did, interact directly with the data layer. It's an exciting new opportunity to digitize business processes. Now, we quickly wanted to go into what is an agent and then touch base on the main reason for this talk, which is a PromptOps flow, right? How we need to rethink our CICD process when it comes to the logic artifact that's defined in the prompt. An AI agent calls a large language model, right? We've touched base on that now many times. It gets its input or task from a user, instructions from a prompt, right? Second logic layer next to code is prompt. It can retrieve memory, right, from a memory database. Typically, these are vector databases, and the memory retrieval happens via some semantic similarity assessment. And then, very important, it can call tools. Tools are other backend APIs, so other Software 1.0 applications, other Software 3.0 applications, or data layers, right? Some data pane, HANA database directly, some data lake, whatever it might be. And so now I specifically wanted to take a look at what all will change, right, in our development pro applications over Software 1.0 applications. We talked about the core logic artifact a lot, right? Want to go a little bit more into the trickle down of what that means, that this core logic now doesn't only sit in code anymore. Version control, for example, this is what we're going to take a look at today, will potentially drastically change, right? A prompt is just text. A prompt does not need to be compiled. A prompt does not need to do unit test coverage. A prompt can't do a linting score. A prompt can't be assessed for open source license compliance, right? It's just text. A prompt, and therefore an application with prompt and code will have a different testing focus. I can't test for functional correctness the same way. Why? Because if I have a golden test set, well, the output won't be ever exactly word for word the same as what's in my expected output in my golden test set, right? The content might be the same. The meaning might be the same. The tone might be the same. But word for word, if I'm asking ChatGPT twice in a row, what's the weather in Berlin, it won't be word for word the same answer, right? Because of this inherent fuzziness. So we need new mechanisms to now test. We can't do unit test coverage alone anymore. We can't do, as we did with Software 2.0, just F1 score on the test set, right? To assess. We will need something like LLM judges. We will need complex new evaluation structures to still assess how good is this agent and should it move from dev to test to prod, for example. Monitoring will be very different, right? Traditional hard-coded application logs will be one part of it, but they won't be enough, right? This notion of AI traces is, being brought into the industry as the new default way to think about agentic AI-specific application logging. right? The brain or thought process of the agent. So specifically a logging mechanism that's looking at what goes in and out of the LLM as the primary source of truth, right? And the primary explainable AI artifact, right? Rather than just the hard-coded application logs. So a lot is changing here. Then when we think of the build phase, deployment mechanisms, release management, a lot is changing there in the actual CD part of our CI/CD pipeline, right? We don't need to compile it anymore, potentially, at least the prompts we don't. We can think of them as a configuration at runtime parameter. Potentially updating an app's inherent core logic within milliseconds, right? This obviously, again, bears risks, but it's first and foremost an opportunity and a possibility. I think the continuous improvement loop is the biggest change of all, because if we want to change how a software 1.0 application works, we have to go in and physically change the code, right? So this means we have to open a GitHub pull request, for example, right? And this is manual process, takes time, right? It's not something that we just quickly do. It takes Jira tickets and then a Scrum team working on it, etc. Well, here with Software 3.0, with this memory layer, I think this bears insane opportunities because we can have human feedback directly integrated into the memory layer as a vector, right? An embedded vector in a vector database. Hey, agent, last time you processed, let's do, I don't know, cash collection. The agent's processing an invoice for us, right? To follow up with a customer on an invoice that's overdue. Hey, next time you see an invoice that has this and that criticality level, you have to be more harsh in your tone, and you have to tell the client to, I don't know, pay interest or whatever it might be, right? This is just an example for an agent app like that. But that feedback can be, without changing core prompt or code, inserted into this memory layer of the agent, and the agent can go back and remember next time it's processing a similar case that, oh, the human has given me feedback for this. I need to memorize and now change. And essentially what this triggers down into, what we could translate it to on technical terms, is dynamic prompt adjustment at runtime, right? The base prompt stays the same. This feedback gets added like a few shot prompt, just a concatenation of the base prompt plus this, retrieval from the memory as a then dynamic prompt adjustment at runtime that can then change the behavior of the agent without having to change the core prompt or change the core code and make it better over time. And so I think this is something that's super transformational and that we'll have to think and look at very closely when we design these systems. That's kind of my high level overview on what I think will change when it comes to building these systems. Today, now, I want to take a deeper look into this deployment mechanism, so for prompts alone. So the base paradigm for this is that we have to separate the prompt from the code. Right, so prompts at the core are still, of course, a Git problem, because I can have two developers working on the same prompt and they can have different versions and they have to be merged together somehow. So I still need to solve merge conflicts. So I think prompt creation will still happen in a environment that is Git-like or potentially even Git itself, so GitHub. But then the lifecycle management of prompts and the deployment of prompts, that most likely will be different, right? I think code is still in GitHub, that's clear, but prompt registry will play a role for lifecycle management of prompts, right? Which prompt is on dev, right? Supplied to the dev agents and prod, right? The pre-prod, whatever. And so there, if we do a very, very, very simple, this is just a high level concept, right? But when we look at a simple 3-tier landscape for our agentic application, dev and prod, and we think of these two logic artifacts, code and prompt, then we have code version and prompt version defining uniquely the application in that landscape. That's not entirely true, right? We still have the memory layer that plays a role in how to define the agent and what the agent can do. And we have the LLM, right? So if we use a fine-tuned LLM over generic LLM, so those two levers are still there as well, but I want to omit them for simplicity right now and say, in my example, I have 3 landscapes, dev and prod, and I have code version and prompt version defining uniquely my application. And I'm assuming here I have code version 1 and prompt version 1, CV1, PV1 deployed on int and prod. And on dev, I'm just changing that. I'm changing to code version 2 and prompt version 2, right? And so what does that mean for the process? Well, I have a developer potentially changing the code on GitHub, right? And then with at SAP, we have Hyperspace for CICD to do build, test, scan, deploy processes to essentially deploy a new, think Docker container, right, on a hyperscaler, on SAP BTP, ideally, of course. That can change the CV part, right? So I've changed it to code version 2. Prompt version 2, and I have quality gates, of course, now on how that code version will propagate from dev to into prod, right? What will allow me to roll out the code from dev to int, what will allow me to roll out the code from int to prod. It'll be some semantic and functional code correctness measure that will determine the quality gating for this. Now, when I look on the prompt side, right, the prompt engineer or developer that changes the prompt might still do it on GitHub, right? I think that's not fully clear yet, depending on whether we have native Git integration with the prompt registry, because we still, if we have many people doing it together, still need to serve or solve Git problems at the core with merge conflicts, different versions, different developers, and so on. It'll still be branches in some sort. But then once that's sorted out and the prompt's created, and you just say this prompt now needs to go to dev, I think we don't have to have it on GitHub anymore. I think that we'll see these prompt registries and we'll see a prompt push, right? Similar to Git push, we'll see a prompt push, and the prompt will go to this prompt registry onto its environment and onto a stage, for example, the dev stage, right, to begin with. And there we have now prompt version 2 on the prompt registry on dev. And what that means for our application that's deployed on dev is simply my prompt is outdated. If I have a continuous lookup, right, or I'm even pushed by the prompt registry to go fetch a new prompt every time a new prompt gets updated there, then this dotted line is a configuration and runtime parameter. There's no hyperspace needed in between, right? We don't need Jenkins, GitHub Actions, Azure DevOps, whatever. We don't need to build a Docker container. We don't need to do any code compilation. We don't need to do, any security scans. We can't. It's just text, right? So in theory, a prompt change within a millisecond, right, can completely update and change here the logic artifact prompt version on our application on dev. Now, what we should maybe do now that we've drastically changed the logic of our application is assess if that was good or not, right? So obviously we've already developed our prompt, so we think it's a good candidate and all, but we have to have some agent ops layer, something to replace our traditional CI/CD quality gating with, right? And I think MLflow on Databricks here is a front runner for this, where they have evaluation tracing and an agent improvement framework within their MLflow 3.0 offering. And what we're, for example, doing now is we are kicking off from the CI/CD pipeline when a prompt gets changed, pushed to the prompt registry, and then read into the application at runtime. We're pushing now a new evaluation pipeline, right, on MLflow that will go in and investigate this new performance, right? So we'll get a new run on our agent ops platform that will say, okay, this new pairing between code version 2 and prompt version 2 now has this agent performance on the test set. And if you double click into that, it's quite interesting. I mentioned this previously, that of course the agent performance won't ever be the same. So in our evaluation of agent performance, we now also need more agents, so-called LLM judges, that might not assess that one-to-one, the output is exactly according to the golden test set, but the output might be correct from its meaning, from its content, from its tone, right? Going back to my cash collection agent example from earlier, the output of the cash collection agent could be an email, for example, to my customer, has the same meaning, has the same tone, it's got the same output effect, but word for word, it's not. Well, then, of course, my application is still correct, it's still good, it still performs well. And I do that now across tens of thousands of test sets and test cases, and I can then score my agent performance in a metric-like system, right? Asking my LLM judge output, for example, to be a number between 1 and 5 on how correct is this output, how professionally written is this output, how good is the tone of this output, was there specific thing integrated in the output that I wanted, was the agent able to capture that, was the agent able to use a specific data type or data sources input that I would want to be reflected in the output. And so all this can happen on the trace that the agent created, right? Which is, again, the application logging specific for agents. And on that trace, we perform the evaluation. And in that way, we can do any subtask evaluation or overall input-output evaluation. of the agent, and can very closely monitor then across the entire test set agent performance over time with different code version and prompt version. And that becomes our quality gate to then decide if this code version, prompt version on dev should be rolled out to int and to prod. Now I've done a very deep thought experiment with you guys, right, on how CI/CD needs to change. This is, of course, a high-level view. I think we'll have to see more specific frameworks. MLflow is a thought leader in this space, surely, and we will have to see, big software companies like SAP. I think we're a front runner there too. Assemble this then into paved roads on our CI/CD offerings so that developers can build good software 3.0 applications all around the world. And with that, I come to the end of my presentation for today. Thank you so much for listening. Hopefully this inspires you, gets you thinking in different ways on how to build CI/CD and other processes around your software 3.0 applications, because we don't only have to build the core logic, we have to ship it, right, and bring it into production so that customers can use it and therefore benefit from our new software 3.0 apps. Thank you so much, everybody. Take care. Enjoy the rest of your day. Back to you, Nora.
Hi, sorry. Actually, this is the real truth of parenting. I'm alone with my kids, and obviously the little one needs a diaper change right now. So I had to run over because he was crying like crazy. But that's too much information. Okay, let me check the chat. Somewhat philosophical to think about it, Vitali says. I completely agree. I actually have also something to add. I never thought about the fact that you have a code version and a prompt version. And it's ridiculous because, like, obviously you do, but for me, that was just kind of like eye-opening. Because I somehow always, when I code an agent, I kind of consider the prompt part of the code, but it's not. It changes everything. So that was a really good point. I really like that.
You can think of it as code, but then of course it needs to be deployed with the code, right? And
Yeah,
every prompt change requires you to build a new Docker container, deploy
yeah,
it,
yeah,
and
yeah,
all that stuff,
for
right?
sure.
And if you separate it out, you have this new CI/CD world that opens up for you that
Yeah,
has opportunities, right? And I think over time, more logic will be prompts, and then
yeah.
less cost, right?
Yeah, for sure. And I mean, it doesn't make, as you said already, it doesn't make sense to change the code every time just because of your prompt. But I mean, I built so many POCs that I never really thought that through, to be honest. Yeah,
Yeah.
that was very eye-opening for me just now. And we have no questions, which is weird. But yeah, if there are any questions, you can also always write them in the comments and then Max will answer them. Thank you so much. It gave me such a new perspective. I'm gonna think about how I structure my stuff. But with POCs, it's always like so I don't know, like you just want it to work and then you show it and then the demo is done and then you kind of forget about it and you have this very nasty GitHub repository somewhere that you hopefully never look at again.
Yeah,
It's
for
something I
production
want to
apps,
work
you
on.
hopefully don't do that.
No, 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 obviously not. Well, thank you so much for being here. Thank you so much. It was our last talk for today and one of the last talks of Devtoberfest. Tomorrow is the last day. But don't worry, everyone, you can still see us at TechEd. If you can't join in Berlin, just make sure you join the virtual TechEd and we see all of you there. Are you going to be at TechEd, Max?
I will not be at Tech Ed this year, no.
You will not be at TechEd. Sucks. Actually. Okay, cool. Then thank you so much, everyone, and have a good evening. See you next time. Thank you.
Thank you
Bye.
guys. Take care.
Okay.